Okay. So we're going to continue our discussion on testing, unit testing, and JUnit. So last lecture, we took a deep dive into defining what is testing and why is it important. Then we looked at unit testing versus functional testing. And then we really did focus in on the advantages of unit testing. And then we took a quick look at JUnit, which is the most popular unit testing framework available in Java. And so I want to follow up with actually doing a demo of JUnit testing using IntelliJ. So in today's lecture, we'll go ahead and it'll be a little bit more implementation driven as opposed to theory driven like the last lecture was. So we're going to do effectively a demo over the course of today's lecture. The demo we're effectively going to be doing is using JUnit testing on a baking project that we'll develop as we go ahead and call through this. So before we can start developing our baking project, we have to make a new project in IntelliJ, and we're going to name it banking. And then we'll also go ahead and create a new Java class named BankAccount. So let's get some of the core components of this done. If we want to go ahead and do this, so let me go over here. I have IntelliJ opened. I'm going to go to new project. I'm going to select that here. Okay, it's going to give me the option to go ahead and give this project a name. Here for this demo, I'm going to call this banking. And I want Java. I want my build system to be IntelliJ. I'm currently using Java 18, but select whatever your JDK is here. I'm going to go click the create button. And let me expand this out so you can see my desktop that's completely disorganized. Then I'm going to go into SRC, my source directory here. Now that it's created a banking project, now that IntelliJ has created my project here, I will now right click. So I go to new. I'm going to select a new Java class right there. And we're going to name this Java class BankAccount. And I'm going to hit enter on that. And it's going to go ahead and generate that new class file. And if I go ahead and unpack the source code file here, I can now see I have a BankAccount class right there. Perfect. Okay, so now that I have made my project and now that I have a new class, why don't we go ahead and create just a simple BankAccount implementation that we can use as our background, as our subject for testing. So here, we're just going to do our typical class declaration of a bank account. We're going to say our bank account is effectively going to have three different instance variables. So there's three different attributes that's going to define a bank account. A bank account will consist of a first name, which we can model as a string. A bank account will consist of a last name, which we will go ahead and model as a string. And a bank account will also go ahead and have a balance, which we'll go ahead and model as a double. Since these are instance variables, we'll make sure to label those as private. And since this is a class here, we must define our constructor so we can instantiate off of it. We're going to define the constructor such that it takes in three different parameters, one for the first name, one for the last name, and one for the balance. We'll take those values that are passed into our constructor, and we will bind those to our instance variables. And then what we'll do is we're going to create a couple of special methods that we think are what define the behavior of a bank account. So one of those is going to be the concept of a deposit. So for a deposit, we're going to expect an amount, and we're going to expect whether this is a branch bank or not. So you have out of branch banking and you have in branch banking. So that we'll have two parameters, the amount that should be deposited and whether this is in branch bank. And then what we will do is we will take the amount that's passed in and we will just add that to the current balance. And then we will return the new balance. So here, the return type is going to be double. Besides being able to deposit into a bank account, we also want to have the ability to withdraw from a bank account. So again, we'll have two parameters in this method where we will go ahead and be able to supply an amount in the form of a double, and also whether this is an in branch or out of branch for our banks, that'll be a Boolean value. And so here, when we withdraw, we'll take whatever the amount is, and we will go ahead and we will deduct from our balance and then return a new balance. So we'll have a double return type there. Now notice we're implementing this in such a way that it could be very risky, right? Like if a user were to pass in a negative number, then a deposit would become a withdrawal, and a withdrawal would become a deposit. So clearly, this is when we would define our insures and our parameters such that the double value has to be a positive. It has to be 0 or higher for that to be valid. So that would be part of the contract that we would establish with our client. And we would define that inside of our Java docs. So it would show up in our API. But right now, we're just going ahead and implement just a very, very basic implementation here. And then one last method will just allow us to be able to get the balance. And so here, there's no parameters here. We'll just go ahead and access and return whatever value the balance is. So we'll have a return type of double there as well. So if there's no questions as to the implementation of this, what I will do is I will just copy this and go over here, and we will now go ahead and implement that into our BankAccount.java file. And so now here I will save this, make sure that's saved. Okay, so now that I actually have a bank account class file, relatively simple one here, why don't we go ahead and start to set up our JUnit project. So here, what we want to do to make it easy is we want to use IntelliJ to add JUnit into our banking project. So in order to do this, we can right click on the class name bank account, which will open up a menus prompt, the menus option. And when we do that, we can see one of the menus, one of the options we'll have here will be generate. So I'll click on the generate, and it'll give me a lot of different options on what will be auto-generated into my code base. You've already seen me be able to auto-generate things like constructors or getters and setters, or both the getters and setters, or like your equals method and your hash code method, or the toString method, or any kind of override methods. Here, one of the very last ones, though, that we're going to be interested in is going to be this test ... So what we're going to want to do is we're going to select that one, which will then bring us to this new prompt that'll say there's no test routes found. And then it's going to ask us, do you want to create a test in the same source root? And we're going to hit OK to that. Okay, so let's actually do this. So I'm going to right click on here, and it's going to bring up this prompt. I'm going to select generate. It's going to give me the option to test. I'm going to select test, and then here, create test in the same source root. Okay. And here, the next prompt, and we can see this here. The next thing it's going to allow me to do is it brings up this create test set of options. The testing library by default should be the newest version of JUnit. So we're currently on JUnit 5. The next option will be, it will ask JUnit 5 library was not found in your module. So it's going to, IntelliJ is going to try to fix that for you. Now, when we go to build a test, since we clicked on the class name, bank account, what it's really trying to do is to create a JUnit test class for that particular class file. And that's exactly what we want. And if you recall from last lecture, the convention to name your JUnit test classes is to use the same class name as what you're testing against. So it's going to be bank account, and then you affix to the end of it test. So bank account test. Then after that, you can select inside of this little pane here which instance methods you want to build JUnit test methods for. So here, what we'll do is we'll just select all the checkboxes. And then once we're done looking at this prompt, we're going to select the OK button. Okay, so let's go over here and do just that. So I'm happy with JUnit 5. I want to fix my, I do want to fix my module. I want to use the default class name, BankAccountTest. And here I'm going to select that I want a test method for deposit. I want a test method for withdrawal, and I want a test method for get balance, and then I'm going to select OK. And there it goes. It does it for me. Now, I want you to notice I have some squiggly lines here, and I have some red text here. So squiggly lines means there's error in those source code files or in those directory. Inside one of these directories, there's a file that has an issue and therefore can't compile. So squiggly red lines means that there's something you have to fix. Anything that's in red text represents like a keyword that can't be identified. So like if I scroll over here, and just put my cursor over so I can focus on what's red, IntelliJ will report to me, hey, I cannot resolve the symbol JUnit. That's because we don't quite have the JUnit class path set. But we're going to move on. So here, yeah. So this is the result from the test setup, just like we saw previously. And like I mentioned prior, the red text and squiggly lines highlights that there are errors in our source code. And so there's one of two ways that you can kind of determine what is going on with your source code. You can either put your cursor over it and a little pop-up window will appear, a little pop-up thing will appear to let you know what it is. Or you in the top right-hand corner, they'll show what errors and what warnings you have. And you can also select to see those. So let's take a look at that. So here, I'm getting my report there, cannot resolve symbol JUnit, cannot resolve or I can come up here to see my 4 errors and 5 warnings. And if I actually click on that, it's actually going to bring me up a pane that'll show me what all the problems and what all the warnings are. So instead of having to individually kind of scroll over each one of those pieces of red text, I can see in a list item fashion everything that's kind of gone wrong here. And one of the nice things about this is IntelliJ has an approach of trying to resolve these issues for you. And so that's what we're going to go ahead and utilize. So what I want to do here is I'm going to select the first issue that I have, which is that we cannot resolve the symbol JUnit. And when we see that, what that means to us is that the keyword, the package JUnit, so clearly we're trying to access this package JUnit when we go ahead and build out this test class file. It doesn't see that. And what do I mean by it doesn't see that? Well, by default, if you want to import any code into your project, it's got to come from a couple of different places, right? So by default, you have access to import all of the standard libraries that are included with Java. And then any class files that you make that are local to your package, that are local to the directory you're currently working in, are automatically also imported so that your other class files can dereference those, can use those and access those. Now, JUnit is its own separate framework. And currently, if I were to look at the external library, so this is all the things I can currently import into my project. So fortunately, IntelliJ lets us kind of survey this and kind of see what we have access to. You'll see we just have the standard library stuff here. So it's all just the Java-based compiler, some JDK stuff. But if I were to look for JUnit, it's not there, right? So as of now, when we first built out a project, we're just giving the standard library. And so that's what it's letting us know, is that we tried to generate a test class, but we don't have access to JUnit. So what we're going to do is we're going to right click on the error from our menu option, and it's going to give us another option, right? It'll allow us to show some quick fixes, and we're going to select for it to go ahead and do those quick fixes. And then it'll give us some options. So really the options we need to do to fix this is we need to import, or we need to define a new class path. So a class path is essentially a pathway that goes to Java classes that are not part of this current project and that are not part of the Java standard library. And so since JUnit is not part of, it's not something we built ourselves, and since it's not part of the standard Java library, we're going to have to add a new class path so that we can access all of the classes that are defined in JUnit. So for IntelliJ has 2 defaults already on there. Actually, there's 3 different options. The first is to use JUnit 4 class path, which we don't want to use. We want to use the most up-to-date version of JUnit 5. So we're going to select the second option. Or the third option is JUnit is typically packaged into what's called a jar file. You can think of that as like a Java executable file. Jar is short for Java archive, which we'll see how to deploy. It's one way you can deploy your Java code. And I'm pretty sure we haven't covered that yet in 1583. So we will look into making our own jar files later this semester. But that's just another approach that we could use to define our class path here. Here, we're just going to select the second option because we can allow for IntelliJ to install this dependency for us. That's one of the beautiful things about an integrated developer environment is it's packed with a lot of different functionalities. And so what that's going to do is it's going to open up a download library from the Maven repository. So what the Maven repository is Maven is a build tool. There's another build tool that's called Gradle. I'll try to, if we have time this semester, explore building a project with either Maven or Gradle, because in industry that's very popular to be able to actually build your projects with build tools. Right now, we're actually using a build tool, but we're selecting IntelliJ as our build tool. So what a build tool allows you to do is it allows you to define external libraries you want, and then it goes to a well-known location, a well-known repository. It grabs those dependencies and then it downloads it for you and then sets your class path to it so you don't have to manually do that. So again, this is just one of the big advantages that you get from having a IDE and having a build tool. And again, things you should be aware even exist because this is what you would use in industry. So then we would just select OK here. So let's go ahead and do that. So here I'm going to right click. I'm going to select, hey, I want to show me my quick fixes. I want to add JUnit 5.8.1 because that's what I'm currently using. And then it's going to give me the option to download this library from the Maven repository. And so IntelliJ is consistently updated to have references to all of the new versions. So we don't have to worry about versioning out our external libraries, which again is great. So I'm just going to hit OK on that. And bam, it's that easy to now add JUnit to part of our class path. So now we can make use of it. So instantly you see all the red squiggles go away. You see that the red text has gone away. And now I can start making and running and executing my JUnit test class. And so here, notice it even goes ahead and defines that import for us. So what's happening here is you're already familiar with import that allows us to bring in classes from outside our system into our system. Here, this is the package. So recall whenever you use the dot operator, that means that you have effectively one package inside of another package or a class inside of a package, right? So here we might have the class assertions, which is inside the package API, which is inside the package Jupyter, which is inside the package JUnit, which is inside the package org. And really, you could think of this, whenever you see a dot, you could think of it as a file hierarchy. So you could replace the dot mentally with a slash. You could think of the top level organization of where this code resides at as being org, and then a subdirectory of JUnit, and then a subdirectory of Jupyter, and then a subdirectory of API, and then finally an assertions class, and then we're just going to pull all the methods from assertion using the asterisk. And so we'll learn more about how we can create our own packages in the future. But this is just a very common approach. One reason why, so it's by convention, and again, I don't want to get too much detail on this lecture, but just by convention that typically your packages are named as unique things. And so Java typically uses the URL, an entity's URL, to create a unique identifier so that any package you create is distinguishable and different than a package that anyone else might make. So we're guaranteed uniqueness with this naming approach. And so we've probably never seen a static import yet. Really what's happening with the static import is there are static methods defined inside of assertions, and that allows us to go ahead and plug in the holes, because that's what you do with a framework. A framework is a mostly implemented application with some pieces missing. And so our bank account test will implement those missing pieces, and then it will use this to go ahead and then run the test. So effectively, JUnit has all of the background stuff pre-implemented. The only thing it doesn't have implemented is the things it can't know, like how to test this particular class. And that's what we're about to do. So you're going to see when it builds this out for us, it's also going to give us the annotated. It uses an annotation. That's what this @ symbol is for test. And so test is actually defined inside of the JUnit package. So technically, this annotation exists inside of org.junit.jupyter.api.test. Now, if I wanted to, I could import. I could do this. I could do an import of something like org.junit.jupyter.api.test, right? I could do that. And if I did that, I could just do the annotation of test. You see? So provided I import from the fully qualified name, and the fully qualified name is whatever the name of the class or annotation or whatever it is, plus its entire package, then I can just use it by its kind of its relative name. However, I'm just going to keep it as it were, as it was pre-generated. So I will put that back as it were, but just know that that's an option. So if you just want @test as opposed to this entire long thing, that's possible. Now we need these annotations. Each one of these test annotations will define to JUnit what method to call as a test method. So we had pre-selected when we generated this that we wanted deposit to be a test method, we wanted withdrawal to be a test method, and we wanted to get balance to be a test method. So right now, we can actually run this. If I were to go, and they have a couple of options here. Notice they actually, when I look in this pane here, right next to the left of all of my source code, there's a couple of green arrows. And those green arrows represent where in my application I can actually start running it, executing it. So if I want to run all the tests, I can click on the double green arrows. If I want to test just a specific method, I could hit on the single green arrow. So notice there's single green arrows that line up with each of the methods, and there's a double green arrow that lines up with the class itself. Okay, so we'll go ahead and run that. Before I run that, though, I do have a quick question, and I just want to make sure that it's resolved. So I have a question. What does the static keyword do in that import clause? I believe I covered it, but let me just reiterate to make sure that everyone's on the same page. So when I use the static keyword in the import clause, it gives me access to the static methods that are defined inside of this assertions class. Now, the reason why we have static methods in the assertions class is because it allows us to use these annotations and build out our own kind of class file. And it will be it'll allow us to utilize the static methods inside of our test class so that they exist. And then what will happen is JUnit will then create an instance of our bank account class and actually invoke it and then run all of the test methods in there. But we want to use part of the JUnit framework to do the actual testing, to be able to assert that some sample data is equal to what we expect it to be. And so in order to do these evaluations, JUnit created a lot of static methods that we have access to right away just by importing those static methods without having to instantiate anything within JUnit. So this way we don't have to know any of the dependencies in JUnit. We don't have to know any of the way that objects are created. We can just use those methods because they're defined as at a static level. So we could just use like assertEquals or assertTrue or assertException, which we're going to see in just a moment. Does that answer your question some? Excellent. So now what I want to do is I'm going to select the double arrow and I'm going to run all of my current test methods. So let's go ahead and do that. I'm going to click on here. I'm going to right click on it. And it's going to bring up this prompt where I can go ahead and either run the bank account test or debug the bank account test, or I can run with coverage. These are all different things you might use in industry, depending on what your team requires, but we're just going to run this right now. So this is actually going to run the JUnit tester. And so here it's compiling it. And here in the bottom is the results of my run. Notice when I do JUnit testing, it actually lets me know here at the class level, I will either get a check or an X. A check means that I've passed, that my class has passed entirely. The only way that a class gets a check is if all of its test methods, all of its test methods are successful. Now, each of my test methods in here also have a check, and this shows when each individual method went ahead and what status it has. And then any kind of data that gets processed will actually then display inside of here, inside of this pane to the right of there. It also gives me some things here. It shows me the test passed, 3 tests of 3 tests were passed. It gives me timestamp. So it took 49 milliseconds for me to run through all my tests. And here also at the very bottom shows me my test passed 3 and then a minute ago, how long ago I tested it. So this is it's really nice. Using JUnit is really nice because it instantly highlights what parts of your code are working the way you expect and which parts aren't. Now, right now, everything passes because we don't have any implementation inside of our test methods. It's all stubbed out. So by default, there's nothing that failed. So this isn't typically the way we want a JUnit test class to start. We actually want all of our test methods to start out as failures. And then we want to then inspect them and work with them until they pass. So just think of this. It's very dangerous test case where the default status is for passing. So we don't want that. We're going to fix that. That's going to be the first thing we want to learn how to fix, is to make all of our test cases become false by default. Yeah, so it works, but they all pass by default. So there's a method called fail that forces a fail result. And so here, let me just grab one of these so I can be lazy. So let's go over here into each of our methods, and we're going to give it a fail. Here, we're going to give it a fail. And here, and again, this fail method is defined for us inside of JUnit. Like if I scroll over here, it even shows me where the dependencies are and everything. Right here, it shows fail is a static method defined in org.junit.jupyter.api.assertions. So again, that's one of the static methods we want to make use of. And so it shows me what version that is in. And here, notice it actually shows me that the class path we're importing to use J is actually a .jar file. So that is a essentially deployed Java file. And then notice here, it even gives me what my contract is and all this other stuff we use for testing. So effectively what the fail method requires, one parameter, it's a string, and it's the message that's going to get reported into our pane if this goes ahead and fails. So now what should happen is if I go ahead and test, so I'm going to right click on the class here on this green arrow, and I'm going to tell it to go ahead and run that bank account test again. And so what I wanted to do is, yeah, exactly what's happening here now. So I want an X for my bank account tests and for all of my individual methods. Since we haven't started implementing our testers on there yet, we have a failed test on our withdrawal, our failed test on our get balance, and our failed test on our deposit. And here inside my pane, you can see I have this message. So I get an assertion failed error with the message this test has yet to be implemented. And it's going to give me that report on each of those. And then also gives me a stack trace to let me know what led to that failure. But we already know it's calling this fail method. And okay, now it's going to go ahead and give me the red squiggles to say, hey, your code is broken here, but it's supposed to be broken there. That's the entire point of that method. And again, at any time, if you have any questions about what we're demoing out here, just go ahead and ask in the chat and I'll address it as I'm walking through the source code file. Okay, so what we just did was we ran all of the tests, right, using the double green arrows that's associated next to the class. And here, what we expected was all of our tests to fail, which happened. So, and in fact, you could see here, it also shows tests failed. So we failed 3 of 3 tests. So instead of showing what we passed, it's in the red. And also here in the very bottom, it's letting me know the error messages I'm getting. Excellent. Okay, so the next thing I want to do is I want to show you one of the assert methods we can use to start evaluating our expected values versus the actual values. And so that's how we're going to determine whether we pass or fail the test. Is we're usually going to invoke a method, the one that we're unit testing. So recall with unit testing, we're testing a piece of our class at a time. And the most elementary part of a class is its methods. So typically we're testing a class, a method at a time. And so each method will have some behavior where we expect some type of output based off that contract we designed, right? Based off the contract we defined. And we want to test if our actual value corresponds with the expected value. And so one of the most common methods we'll use from JUnit is going to be this assertEquals. So just to highlight this, we're going to create a dummy test method, which will be run by JUnit because we'll use the annotation here at test, right? And we're going to call the assertEquals. And just so you know, just like anything else in Java development or in any kind of development, there's an API to support what you can do. So for the assertions class, right, I could go to the JUnit documentation, the API page, and I can see all the different types of asserts I have. And so it's going to be laid out in much the same way that Oracle does, because guess what? This documentation that you're seeing here was produced by Java docs. So almost all Java documentation you're going to see is going to be formatted the same for that reason. And so that consistency of formatting is super critical, which is all the more reason why everyone should start getting comfortable with using Java doc comments so that you can produce this documentation yourself. So here, if you want to peruse, you can see you can do things like assert all, assert arrays equals. They have assertEquals, and you see it's overloaded with a ton of different types of inputs as the expected and the actual. But at the end of the day, it's all doing effectively the same thing, where it's going to just assert that the expected value here and the actual value are equal. So that's one of the most common ones we'll use. So we'll make use of that and just make a dummy test method just to prove that concept. So let me grab this code here, and we will add this into our bank account test. And then we'll just run this one individual method. And so I have a question. Will these PowerPoint slides be made available to you all? Yes, I will go ahead and publish these PowerPoint slides so that you'll have reference to them. And they'll just be mindful that they might be a little rough. Okay, so here I have the annotation at test. I have the method here, dummy test. And the dummy test will simply call assertEquals. And if I highlight over it, I can see assertEquals is a static method. And again, that's what that import static does. And it just takes in an expected and an actual. And so notice it knows which of the many different assertEquals to use based off of the parameter values passed in. So since I'm passing in an int, integer values, it's going to call the int version. So another nice thing about IntelliJ is when you pass in your parameters, or your arguments to your method, it'll actually illustrate what the keyword is, what the label is inside of the parameter list and so here I know that the number 1 represents the expected value and the number 2 represents the actual value. And again, the entire point of hard coding these values is to show you what happens with assertEquals. So here I'm going to just click on this one method. I'm going to tell it to run the test on that. So we're going to run that dummy test method and give it a moment. And there we go. And we can see here the output is going to show that my class failed. And I only ran that one method, dummy test. So it's going to show test failed 1 of 1. And here it's going to show me what went wrong, that the expected value was 1 and that the actual value was 2. And then I can even click here to see the difference. And then it gives me the stack trace here to illustrate what code ran, what collection of methods ran, which led to this failure to occur inside of my unit testing. Next, I'm going to delete that now because I just did that as a as a proof of concept of how we're now going to start building out our test methods so that they're actually evaluating each of the methods we want to go ahead and evaluate. Okay, so we ran this and we saw that JUnit creates a test fail and then logs both the expected and actual values. So we accomplished that. So now the next thing I want to do is let's actually define or implement the stubbed out test method for deposit. So here, let me grab this and then we'll talk a little bit about what it does. So let me go into deposit. So here, this is my deposit. Right now, it's just stubbed out and it's just designed to fail. So instead of doing that, let's actually give it an implementation. And before I read out the code, I just want to refer back to illustrate one of the cool things about IntelliJ is as we added the class path, I didn't highlight that after we did that, I can see JUnit here as well. So I just want everyone to pay attention that inside external libraries now, where I have all the standard library stuff, which I was inspecting before, is now inside. It was always inside the directory for where my Java JDK files were at. So in addition to that, I have this other class pathway that my project is making use of, which is JUnit 5.8.1. So you can see that is now part of my external libraries. And what's great about IntelliJ is that I can then unpack this jar file and I can start examining everything that's inside of here. And so it allows me to really kind of navigate and know what exists inside of all of my external dependencies. And then if I needed to look anything up, it gives me that option to go and then check the documentation. Okay, now going back to implementing our deposit test method, the first thing I'm going to do in order to test this is I actually need an instance of BankAccount to be made. So I'm going to create a new bank account and recall our constructor for BankAccount, right? Requires a first name, it requires a last name, and it requires a balance. So here we're going to pass in those properties. So I'll pass in as the first name Ted, last name Holmberg, and I'm going to give myself a balance of $100. I'll create a new bank account and I'll store that in a local variable of data type bank account right here in the deposit method. Okay, so now again, the entire goal for what we should be doing inside of this test method is testing if the behavior's deposit is what we expect it to be. So here I will then take my account instance and I will invoke the deposit call on there. And I'm going to pass it an amount to deposit, which is going to be $75. And I'm going to use that the branch is true on that. Now, we haven't implemented any behavior with that yet. So we'll look at that shortly in the future. But right now, after we're done, we should get the new balance back. So we're going to save that into a local variable. And this is where I will then use my assertEquals, where I will then check to see if the expected value here is $175, because I'm starting with $100 and then I'm depositing $75. So what I would expect the result of my balance to be is 175. And then what I'll do is I will then also pass in the value of balance. So this is the expected value. This is the actual value. And then here, notice for double values, there's a third parameter for assertEquals, which is going to be your delta value or the precision for your error rate. So you have actual equality with integers, but with floating point numbers, they're really just an approximation. So it's important that you have the ability to define a threshold that is a allowable equality. So you might say that you might have an error precision rate of 0.1. So as long as they're within 0.1 of each other, that would be considered equal. So that's a very important third parameter to keep in mind with whenever you're using kind of fractional data or approximated values. Okay, let me save that and let's see if we can't run this. So let's run deposit. And it's going to run, and look at this. That's awesome. So here we're actually testing deposit. This is no longer Stubbed implementation, and it is working the way we expect it to, at least in this small instance. Now, if we were building a real JUnit test class here, this is just a demo that I'm doing here for our class, but a real JUnit tester would have multitudes of tests inside of this test method. So it wouldn't just be one invocation to deposit. We would be trying a lot of different numbers to make sure that it corresponds with what we'd expect. And then we would try some of those edge cases that we talked about last time, where maybe you might test with depositing $0 or just like $1, or maybe like a large number of dollars. And then you would try to think of some challenging concepts that might be prone to breakage, so that might be prone to error, and you test those out. So this method would actually have more than this one test case, just to ensure that you're testing it quite at a much wider scope, to make sure any type of data that gets passed into it, your code will be robust and resilient against. But this is great. This is looking good so far. So that is that's behaving as we'd expect. And when we go back here, we can see, yeah, we're currently getting exactly what we should be getting. And so why don't we do the same thing? What we're going to do is we're going to go ahead and implement our get balance. Now, one interesting thing about the getters is it's common unit testing convention to apply a setter and then check the getter. So a getter doesn't really have to be like tested, because all a getter does is it gets the state of one of your instance variables and returns it. So there's not any coding, there's not any processing, there's nothing in there that's error prone. Now, the problem with setters is that they're kind of hard to evaluate. Setters change the state of your object, right? They change the state of your instance. They're mutating, and they're not reporting back. So they silently change the state, and that makes it a little bit more difficult to check what's going on. And so in those instances, what we typically do is we invoke a setter, and then we use the getter to see how the state changed. And then we see if the state changed after invoking the setter in the way we expect it to. So instead of just calling get balance, which doesn't really need to be tested in and of itself, what we'll do is we'll relabel this method to be called get balance deposit, where what we're going to do is we're going to invoke the deposit method, which is going to change the state of our bank account. And then we're going to invoke get balance to see if the state changed the way we expected it to. And so to highlight the fact that deposits are part of this method chaining that's being evaluated here, we're going to go ahead and relabel that. So I'm going to overwrite this. Instead of get balance, I'm going to do get balance deposit. And again, any one of these methods that's annotated with a test will be run by JUnit for us. So here I'm going to do the same thing. I'm going to create the same bank account. I'm going to create a new bank account instance, but with the same set of values. So Ted, Holmberg, and 100. I'm going to set that to a local variable. And then I'm going to call deposit. And here I'll set the amount to $75. And I'm going to set the state to true. And then we'll do account.deposit here. And then what I'm going to do is account.getBalance. So notice this is different than what we were doing with deposit. What we were evaluating here was the return value from deposit. Here, I'm evaluating the value held inside of our instance. So here we're checking to make sure that the state of our instance mutated. So we're calling a setter here, and then we're evaluating the new state versus the expected state. So we're going to assert equal that 175 is equal to the new value here. So let's go ahead and run this individual. I can just go ahead and hit this one little green arrow, and you'll see we do go ahead and pass the class. We pass that method. Excellent. That's exactly what we want to see. And again, if this were a real test test case, we would go ahead and build much more variety in the test. But this is just a proof of concept to get you familiar with what JUnit testing looks like. Okay, well, if we're going to do that with deposit, we should do the same thing with withdrawal, right? We should make sure that the state of our bank account instance changes after we invoke a withdrawal method. So let's go ahead and do that as well. Let's fully flesh this out. So here I'm going to create a new test method. So I'll make sure to annotate it. And then here it's just, it's not going to return anything. We'll call this get balance because that's what we're using to inspect the state of our instance. And we're going to use the withdrawal method to mutate the state. I'm going to create instance of bank account using the same set of values. So Ted Holmberg at $100 balance. We'll go put that into a local variable here. And now we'll just go ahead and try to withdraw $75 from there, which we will go ahead and expect that to be $25. And then we will then go ahead and then use that getter to check the state of our instance to see if it's also $25. And if I go ahead and run that here, we can then see it's going to go ahead, compile, run those tests, and get balance withdrawal. Ran, it was successful, and I have nothing inside of my log here. So the next thing I want to do is I want to refactor my bank account code to make it a little bit more complex so we can do just a little bit more testing. So here, why don't we actually go ahead and implement like an account type, for instance. So here, let's go to my bank account. I'm going to go into here. So here, I'm going to create two static final ints. So I don't want to use a magic numbering. So I'm going to create constants where the numbers, where these labels represent these numbers in a meaningful way within my software system. So one will represent a checking account, two will represent a savings account. And I'll make these public so that they're accessible outside the class, but also make them final or constant so that they can't ever be overridden. And since they're static, they're property of the classes itself. Then I'll make a new instance variable, which will allow us to define a account type. Here, let's go ahead and define a new parameter here, account type. And let's do this dot account type is equal to account type. And so what I'm trying to illustrate here is we can build a little bit of our application, test it to make sure it works as expected, and then we add a little bit more complexity on top of that. So again, we can conform to that implementation, that design implementation and test cycle that we've constantly strived to look for. Okay, so I have that. And also let me create a new method in here called isChecking. And so what this will do is it's going to return back a Boolean value, and is checking, which is just check the return. It'll just see if the account type of this account is checking. If it is, it'll return true. Otherwise, it'll return false. So pretty simple change there. So after implementing that change, let's create a new test method inside of our BankAccountTest class that's going to check our Boolean response. And here, the only reason why I really did that was to show you another really popular assert method. So on the instance where what you want to evaluate returns back something that's already true and false, instead of using assertEquals, we can just use assertTrue. So here we're going to create an annotation so to make sure JUnit can see this method and know this is the method you should run as a test method. We'll create a method that doesn't return anything. It's called isChecking, and we're going to define this for when it's true, right? So I might also want to see what happens if it's false, and I'll make that different test method. And so I'm going to create a new class here. Notice now I'm getting the red squiggle lines here. And the reason why I'm getting the red squiggle lines is, because I've updated my constructor, every one of my original methods is now broken. Oh, and you can see how problematic this is. If I'm using my JUnit testing to aid in my implementation, to make sure that I can verify that my classes and my methods are working the way I expect them to, without having to put them into the software system, without having to integrate them first, right? So I can test them in isolation of everything else. But as I'm modifying it, this approach kind of breaks all my other tests, because now I've added this new parameter in my constructor. All my old ones here didn't allow for that. So we're going to fix that. And we're going to fix that in a dry way, right? So notice I've probably been violating the dry principle, because each time I need to go ahead and test, I've been building this new instance of account in each of these methods. And this has worked for me. And usually, again, you'd be building a whole ton of methods. And the reason why you don't want to have them typically as instance variables is because you don't want a previous method to have affected the state of your instance. So because if you're evaluating get balance deposit here, you don't want deposit to have potentially broken the state and then all of a sudden fail this method as well, not because it's something that this did wrong, but because it inherited data from some prior test method. So you always want to make sure that the data you're processing on in each of your test methods is independent from all the other test methods, that it's brand new data that hasn't been modified from a previous test. That's super important. And we're able to do that with the way we've been doing it. But notice as we're updating our class, because it's still in the process of development, we can start breaking everything. Right, so now this one can potentially work, but all the other ones now are broken. I probably can't even run this. Right, let's see if I can even run this. Yeah, it's not. It's going to say my constructors are broken all here, so I can't even test this anymore until I fix that. But before I test this, let's just see what this is doing. So I'm creating. I'm invoking the new constructor here with that new parameter, BankAccount.checking, and notice I'm able to dereference that because since it's static, I can reference it from the class itself. So I can get bank account, and since it's got a constant name of .checking, I get this much more readable thing than the number 1 or number 2. So again, this is how we avoid what are called magic numbers, and this is how we adhere to what's called self-documenting code. Anyway, so we're going to pass in that this is a checking account, and then we'll simply assert true. And then assert true is great because you only have to pass in as the first parameter a truthy value. So this is either going to be true or false. If it's true, it passes. If it's false, it fails. And then the second parameter is the message that you can report into the log on the instance of a failure. So if I want to start running this but prevent the rest of my code from breaking, it might be time to introduce a new concept. And so last lecture, I mentioned that besides the test annotation that lets JUnit know, hey, these are each method that's supposed to be part of my my test fixture. I also can assign an at before all and an at before each to a method. So if the tests don't make any changes to those conditions, then you can use before all. And so before all will just run once before running all the other test methods. So if it's just some basic data setup you need, you'd use before all, but more commonly you use before each, because what before each does is if the test does make changes to your conditions, which is often the case, usually you're changing the state of your instances, then you would need to use the before each, which will run that method to set up your data before every test. So it allows you to reset the conditions for each test thereafter. And obviously it's safest to default to using before each, as it reduces the opportunity for human error, and i.e. not realizing that one test is changing the setup or values of your data before running the next one. So let's take a look at what that looks like really quick. So here, we're going to create an instance variable here to hold our account so that we can access it across all the methods in the class. And then we're going to create a method that's going to be called whatever we want to call it. We'll call it setup here. It's going to be public method so that JUnit can invoke this. Doesn't return anything. And what this is going to do is it's going to set the instance variable to be a new bank account with those values. It's going to be Ted Holmberg with a balance of 100 and as a checking account, right? As the new constructor warrants. And then what we're going to do is we're just going to also print out a system.out message. And I'm going to annotate that with before each here, which means that before each of these test methods gets called, it's going to invoke this method and reset. It's going to update. It's going to overwrite this instance variable so that it has a brand new data, a brand new value for its data, so that they're orthogonal, so they're independent, so they're all operating on fresh data. So if one test fails, it doesn't mean the other tests are going to fail like a sequence change of Christmas lights. So let me go up here to the top, because that's classically where you'd put such a method. Here's my instance variable, right? Private bank account. Here's my before each method, and this is going to be the setup. So now I can remove this. I don't need this bank account because now I can rely on the instance variable. I can remove this one here. So I can now go in here into each of my pre-existing test methods where I was making local variables, and I can rely on the one instance variable. And here, let me remove this one. There. And so the nice thing about this is, as I'm developing, I only have one place where I'm setting up my test data. And so if I mutate the state of my constructor, if I add in more parameters, there's only one place in the test class I need to go to update that. So instead of having to find all those places, which is very error prone, I don't have to do that any longer. And now notice all of a sudden I can go ahead and run this code. And in fact, I'll go ahead and run this in its entirety. Let me move the one that's going to fail to the bottom so that we can see everything else sandwiched together. So here, I haven't implemented this yet, so it's still using the fail, but the rest of these are implemented. So let's go ahead and actually tell this to run this at a class level. So we'll run that. We'll run all of our tests up to this point, and you can see I have one that failed, the withdrawal. The rest of these passed. I have my one that failed, and it gives me my report here. This test has yet to be implemented, but the rest of these, look at this, running a test, running test, running test, running test. That system.out right there got called each time this before each setup method got invoked. So when before deposit got invoked, it ran setup. Before get balance deposit got invoked, it ran setup. Before get balance withdrawal got invoked, it called setup, and what have you for each of your tasks. Excellent. So the next thing I want to do is I actually want to go ahead and update that withdrawal method. So let's go ahead and actually give an implementation here. But here I want to with withdrawal inside of my class bank account, I want to refactor it so it actually potentially can throw an illegal argument exception. So if you haven't seen an illegal argument exception, I'm hoping everyone has at least seen these before in Java 1. If you haven't, we'll talk more about exceptions and exception handling in this class. But right here, what it's doing here is our withdrawal method. Again, it returns back a double, it requires an amount and a branch. But here it's going to check if the amount is greater than 500 and this is not a branch that they have an account in, then we're going to throw an illegal argument exception because that violates the contract. So we're going to create a contract here that you're not allowed to withdraw more than $500 if this is not your bank branch. And so we can ensure this by checking to see if there's a violation inside of that and then throwing an exception on those instances. Now, if we don't throw an exception, then that means we are in a valid state, in which case we can take whatever the amount is that we want to withdraw and reduce the balance by that, and then we return back the balance again. So let's take this new implementation. The reason why we want to take this implementation is I'm going to show you how to do JUnit tester for an exception too, how we can test even exceptions. So let's go to our bank account. Let's go down here. And let's actually go ahead and implement. Oh, we need to get rid of the one that pre-exists. Okay, so here we now have this implementation. Let's make sure that's saved. And again, if you have any questions, just drop it inside the chat channel and I'll try to address it. So now let's talk about how we might actually test that. So first, let's do the easy thing to test and just test on the instance that it does. On the instance that it doesn't throw an exception. Well, that's easy. What we can do there is we have to, let me go back here. We have to obviously annotate our new test method as a @test, but here we might need to propagate the exception if we're not going to try to catch it. So in the instance of if the withdrawal is a branch, we don't have an exception that'll be thrown. But here we'll just throw any exception that might occur because we're not interested in catching it on this instance. And here we'll try to withdraw $60. And this is true that it's part of this branch. We'll put that into balance, and then we'll just do an assertEquals that the balance, the expected value is 40. And we'll look at what the actual value is. And then we'll have our delta value here. So let's just test this really quick. This is pretty trivial, though. It's doing what we've already kind of done prior to that. So let's just implement this and let's test it. Let's run that one test here. Perfect. That looks good. And actually here, since we have more data, I'm actually going to delete that old withdrawal because I want to test for withdrawal branch and withdrawal as not part of the branch. Here's where it gets more interesting, though. If it's not part of the branch, we could potentially throw that exception. So let's see what happens when we actually do that. Oh, and actually, let's walk through the code before so we're going to create a new test method. So again, I need that annotation. So this is going to be an @test method. So JUnit knows to run it. Here, we're going to create a method. It returns nothing. It's going to be called withdraw, not branch. It's also going to potentially throw an exception if it's not an illegal argument exception. We're going to actually try to get that. So here, there's actually an assertThrows. An assertThrows is a JUnit method that can check for a exception. It's going to see if a particular type of exception was thrown. So the first parameter is the type of exception you're looking for. So we're looking for an illegal argument exception. So when you're actually looking for a type of class, then you actually append .class to the end of this. So here, this will look for a class object that gets thrown of an illegal argument exception. The second parameter is going to be what's called a anonymous method. Another name for this is a lambda expression. So you can think of this as a function that JUnit will call that will cause this exception to occur. So we'll talk more about this later, but just understand that this is a empty set of parentheses. So this is like an anonymous function. It's like a function that doesn't have a name because it's only used for this one instance. This function doesn't need parameters, so we're just going to open and close a set of parentheses. And then the arrow points to what is the code block associated with this anonymous method. So here we then have a well-defined code block here, right? Open, close curly braces. And then we can have a set of statements in here that would cause our exception to actually get thrown. So this anonymous function has one statement in it. From the account, it will try to withdraw $600, which is greater than $500, and false for whether this is inside of our branch or not. So we know that this violates what that method allows and will throw this illegal argument exception. So now what's going to happen is when this method gets called, assertThrows will invoke this anonymous method and see if an illegal argument exception gets thrown here. And if it does, we can actually save it. It's going to return that to us. And we can save that into an instance of illegal argument exception here. And then what I can do here is I can then do an assertEquals to see if the message that got defined inside of that I get back from my illegal argument exception is the same from the object that I have saved in this thrown instance. So here, let's grab that and let's actually test to see if we can't throw an exception and catch it, and then see if we caught that exception, to see that even on these edge cases, we can force them to occur and make sure that they occur the way we expect them to. So we can test everything. So let me try testing that. Let's run that. Excellent. So now if I were to test at the top here, everything passes. Excellent. And that represents a well-tested class. And once I do that, I feel that I could then integrate this class into the rest of my software system. So I just wanted to illustrate that here, in this demo, the design strategy that we use is what's called an implementation-driven testing. And so in this demo, we implemented the project code first, right? We implemented our bank account, and then we use unit testing on it. So such an approach is called implementation-driven testing, or just implementation testing. All the times the word driven is removed from that. And that's a really common approach, right? Where you build your code and then you test it. You build your code and then you test it. There's another approach, though, that I want to highlight. An alternative strategy is what's called test-driven development, or TDD for short. You might also see it listed as test-driven implementation. And so the idea here is, and this, in my opinion, is a better approach for designing, especially complex software systems. It reverses the order of what you implement. So in test-driven development, you create and implement your test cases first before you create your project code. So you would create the JUnit test classes, and then you'd build your project code and test it against your text fixture and your test cases. So the reason why you might want to consider reversing the order that we just did here in today's demo is it allows for every developer on a team to use the test classes as a means to mock the interactions within the software system. And so long as your class passes all the tests, then you know it's ready to be integrated into the software system. But what this approach really allows is it also allows multiple developers to be working concurrently on code that might normally be interdependent on each other. So you might have two different classes that both are requesting each other to do things, and you can kind of mock what you're passing in as a parameter and then getting back to make sure it works, so that you can have both Tim and Jill working on two different parts of the program, and they can unit test it and then integrate it as they complete it. And again, the nice thing about this also is that it allows you as a developer to illustrate that you understand what you're implementing. So before you start implementing it, then like the lead developer says, hey, you implemented this method wrong. It's not supposed to return this type of data or supposed to take this type of parameters. You build a test case first that takes in all the parameters and takes out all the return values, and you submit that to the lead developer or the architect, and they can look at the test case and say, yes, this is exactly how these methods have to be invoked and what gets returned back out. And then is your role just to build an implementation that passed that test. And if you do, your job's done. And if anything breaks, it's not your responsibility because you were implementing based off the test. And so then the responsibility for the broken code base is the person who approved the test. So again, it's just a good way of defining responsibility on your code. And so with that said, that I think is a great demo of how you actually do JUnit testing in the real world using an IDE. So when you get to that in lab, keep this in mind. And so for any homework projects, you will have to submit JUnit testing because that's what you should do in the real world, right? And I want to prime you and prep you so that you're well prepared. So I'll take just a small break here so that this naturally cuts.